Hi and welcome to Geeks for Geeks. Today we would be discussing the problem smallest factorial number, and it is tagged as easy in Geeks for Geeks. So in this problem we are given a number n, and the task is to find the smallest number whose factorial contains at least n trailing zero. So it is quite prominent what we need to do from the problem statement itself. Still I would translate it in Hindi so that people would understand much better. तो हमें एक नंबर n दिया गया है. ओके, अब हमें हर नंबर का फैक्टोरियल निकालना है. ओके, अब हमें उस सारे नंबर में से स्मॉलेस्ट नंबर जिसमें एटलीस्ट n ट्रेलिंग जीरोस है. ट्रेलिंग जीरोस मतलब लास्ट में जीरोस. So we are told that we need to find a number which has at least one trailing zero, and then it should be the minimum. So let us first see. Okay, so let us see for one number. So if we go till one number, then this has, and all this has. But what is the minimum number? The minimum number is 5 itself. Then let us see the value of 4 factorial also. Okay, so 4 factorial. 4 factorial has the value 24. The first value where 1 0 is trailing is the number 5 itself. That is why the output is 5. Now let us see for n is equals to 26. Okay, so minimum number which has 6 trailing zeros. So one observation is that if we go down, the number of zeros are increasing. So we need to go from the smallest to the largest. So 3 numbers, then 3 numbers, and 3 numbers, and 3 numbers, and 3 numbers, then again 4 numbers, and then the first point, this is also 4 numbers, in the first point where it is 25. After that also it is 5 numbers, but it is the minimum one. And less than this, no one has 6 trailing zeros. Okay, so we can say that output is 25 itself. Okay, so now we can see that if the value is 10 to the power 4, then we need to calculate till the very large number factorial. But to keep the number factorial without any modded thing or something, it is not feasible even if we use long n, because the number of digits in the number would be very much huge to process. Okay, so क्या हो रहा है ना कि हमें पता चल रहा है कि फैक्टोरियल बहुत आगे तक जाना है. Even if we pre-process the factorial and keep it in an array, then keeping in an array is a constraint here, because as you can see, the number of digits in the number are so huge that we can't keep it in a data type. It is not feasible. So we need to think of something else. Okay. First was that we would calculate for each number. Then the second optimization we thought of is that we would pre-process. But now, even after pre-processing, the constraint here that we are facing is that we can't keep this in an array itself. Okay. So now we need to think of something better. Okay. What to think? Now, I would just tell you. So, if we observe the factorial of 5, okay, factorial of 5 is 1 multiplied by 2 multiplied by 3 multiplied by 4 and multiplied by 5. Okay, so factorial 5, and then we would see factorial 6. It is 1 multiplied by 2 multiplied by 3, then 4, and then 5, and then 6 itself. Then what we would do is we would do the prime factorization also. So now 6 would be converted to 2 multiplied by 3, and this would be 2 multiplied by 2, and rest are already in the prime. Okay, so now we can see that what is the number of zeros in 6. The number of zeros in the value of 6 is 1. The number of values in 5 is also 1. So now we can see this 2 multiplied by 5 is having a value 10. And if you multiply 10 with any number, that is 125, let's say 10 to the power 2, 10 multiplied by 2, all will have at the end 0. That is, the 0 would be constant. So here also we can see that this is 2 multiplied by 5. So we would have 1 0. Okay. So now let us process for something little big, that is 10. 10 has 2 zeros, we know that. So Let us see. 1 multiplied by 2 multiplied by 3 multiplied by 4, 5, 6, 7, 8, 9 and 10. Let us try. So we are only concerned about 2 and 5 because 2 and 5 together makes 10. So we would go to 4 and we would do 2 into 2. We go to 6, 2 into 3. Then we would go to 8 and then we would say 2 into 2 into 2. And we would say 3 into 3. And this is 5 multiplied by 2. We have this. Now let us count the number of 2's here. So 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 2's. How many 5 are there? Let us do it with a red value. 1 and then 2. So 5 multiplied by 2. So if we try to make pairs out of these two, the numbers of 5 satisfying 2 is just 2. So there would be at least 2 zeros. There would be 2 zeros. Let us confirm this. Yes, there is 2 zeros. And you can confirm this for any number as the calculation would be large. So this was the essence of it. Okay. So now if you observe it for one or more numbers, then you would find that the number of 2's would be greater than number of 5 at all cost. Number of 2's would be greater than number of 5's at all cost. हम लोग अगर 2-4 नंबर के लिए और प्रोसेस करेंगे इसी तरह तो हमें ये पता चलेगा कि नंबर ऑफ 2's नंबर ऑफ 5 से हमेशा ज्यादा रहेगा. So why not we calculate the number of 5's and leave aside 2? Because we know that 2 would always be greater than this. Okay, this is just like the same idea. Okay, this is just like the same idea. Suppose my brother reads more than 2 chapters than me, and my mother asks what is the minimum chapter you both have done. So if I study X chapter, my brother would study X plus 2 chapter. Or the minimum is this much. So I know that my brother would always be ahead. मेरा भाई मेरे से 2 चैप्टर हमेशा ज्यादा ही पढ़ेगा. So मैं क्या करूंगा ना कि मैं अपना चैप्टर गिन के वही एज अ आंसर डिक्लेयर कर दूंगा. सेम गोज फॉर हेयर ऑल्सो. मुझे हमेशा पता रहेगा 2 अगर ज्यादा है तो मैं 2 को छोड़ ही दूंगा. मैं सिर्फ 5 को काउंट करके इसी को आंसर मान लूंगा. Now, calculating the number of 5 is very easy. Why? Because if we go to 5, then we can see that it is 5. It is 6, we can go to 5. If it is 10, we can see that 5 into 2. So we find a relation here. That is the number of 5 is equals to the number divided by 5, and that would tell me the number of zeros in that factorial of the number. Number of zeros in factorial of n. Okay, factorial of n. We can do this, but there is more to it. What is more? Suppose if we go to 25 and we divide it by 5 and doing the integer division would make it 5 itself. Would make it 5. Why we are doing the integer division? Because 6 divided by 5 is equals to 5 point something, but there is only 1 5. So we would say that yes, doing the integer division is the best approach. And do 11 also, if we do 11 by 2, that here also we would get 2 point something, but if we go to 2, then we would see that if we go to 11, the number of zeros is equals to 2. Same goes for 14 also. 14 divided by 2. 15 divided by 5 is how much? 3. 16 divided by 5 doing the integer division is 3. That is, we know that in doing the integer division is best. But if we do it for 25 divided by 5, then it is 5. But if we go to the number, then it is 25, 1, 2, 3, 4, 5, 6. Okay, this is one more. So we can say that if we observe this for 25, then 125, then 625, then if it is 25, then we would add 1. If it is divisible by 125, we would add 1 more. So if it is divisible by 25, we would add 1 more. If it is divisible by 125, we would add 1 more. And this would keep going on till we reach the end. Okay, till it is this number 125 or then 625. these all multiplied by 5 is less than that number. Till it is feasible, we would keep adding 1. This is what we would do. Okay, fair enough. Now, if we know how to count the number of zeros of each number, then we can keep all the number of zeros for all the numbers in an array, and that would be feasible. That would be feasible. And we can start a loop and we can go from 1 till the end of the array. We can do this. But here also, if the number that we are trying to find is large enough, then we need to iterate over the whole array. And the time complexity, suppose we need to reach the very end, and time complexity is big O of n. Okay, can we do better than this or not? So if you just observe this, then the number of zeros are increasing. Okay, if we go down, then it is increasing at each step. Okay, and we need to find the minimum point. Okay, so we need to find the minimum point. So it is like this. First, it is no. Suppose, what is this all about? Suppose we want to find a number with 3 zeros. With 3 zeros. First number has 0. First fact number has 0 zeros. The next number has 1 0. The next number has 2 zeros. The next number has 3. Then it has 4. Then it has 5. Then it has 6. Then it has 7. So it is increasing, we know. Okay. So now we can see that for this number, the value is no. Why the value is no? Because this is not a valid answer. This is not a valid answer. This is not a valid answer. This is 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 a valid. This is valid. But we need to find the minimum out of it. That is why the answer would be this. So if you observe, at all cost, this is a monotonous function. Now, what is a monotonous function? You can observe that monotonous function is only n, or only y, or y, or it is y, and then n, or it is n, and then again y. These all are examples of monotonous function, but this is not an example of monotonous function. So we can observe that this pattern is being followed here. That is a monotonous function. Now, if it is a monotonous function and we need to find this point, then we can simply use this as low, simply use this as high, and then we can do a binary search over this. Now, we would find the mid value. So if we find the mid value and it is no for that value, okay, we would count the number of zeros for that value by using a function. And it is no. If it is no, then we need to move. Then we need to find the yes side. So yes side is located at the right hand side. So we would go on right hand side. Moving on the right hand side means that we would do low is equals to mid plus 1. Why mid plus 1? Because the mid value is already checked. If it is yes, then suppose we are at this value, or we can be at this value. The desired answer or not the desired answer. Whatever be the condition, we want to find the first position where it is yes. If we want to find the first position where it is yes, we need to move on the left side. Moving on the left side means that high is equals to mid minus 1. Why mid minus 1? Because mid is already checked. Now let me translate the same in Hindi. मुझे पता है ये मोनोटोनस फंक्शन है, तो मैं एक सबसे छोटा को लो लिख सकता हूँ, सबसे हाई को हाई लिख सकता हूँ. सेम लाइक दिस. ओके, देन क्या करूंगा, आप मुझे डिजाइन करना है कि अगर पर्टिकुलर साइड पे नो हो, अगर नो हुआ तो मुझे यस के लिए जाने के लिए मुझे राइट जाना होगा. राइट जाना होगा मतलब इस लो को उठा के इस तरफ करना होगा. दैट इज व्हाई वी आर टेलिंग दैट लो इज इक्वल्स टू मिड माइनस 1. राइट हैंड साइड चले जा रहे हैं. देन वी वुड बी चेकिंग फॉर यस. इफ इट इज यस, वी नो दैट ये पहला यस हो सकता है और ये पहला यस नहीं हो सकता. कैसा भी कंडीशन हो, अगर पहला यस खोजना है तो हमें राइट हैंड साइड ही जाना होगा. यहां पर बैठे रहेंगे तब भी पहला यस इधर नहीं होगा बट यही होगा, और इधर बैठे रहेंगे तो राइट हैंड साइड यही होगा. सो क्या करेंगे, वो आंसर को सेव करके, बिकॉज दैट कैन बी अ पोटेंशियल आंसर, वी वुड मूव ऑन टू द राइट हैंड साइड, एंड दैट कैन बी आवर आंसर. Now let us move to the implementation. We know how to count the number of zeros by dividing it by 5 and then dividing by 25, 125, 625, and we keep dividing it till the number is large. Then we would go do a binary search also for do that. Now let us first analyze. Suppose we have designed the algorithm. Even before implementing, we can know that if this is feasible or not. Yes, this can be feasible. Why? Because the time complexity of binary search is log n. And for each number, we would be doing divided by 5, and then we would keep dividing by 5, 125. So so this is log base 2n multiplied by log base 5 to the power n. So now this is the complexity that we would have. Now let us see if this is the desired complexity or not. Yes, this is the desired complexity. So yes, we can move forward. Now, as the space is not that great large, so what I would consider doing is, I would consider going to my local editor, then I would code it. The same function is loaded here. I would code it, run it for the sample test case. Sample test case are already loaded at here. Okay. And then I would copy paste the same thing to the Gigs for Gigs editor. Let me know in the comments if this is feasible for further explanations or not. Else, I would just switch back to the GFG editor only. Okay, because this has a better visibility. Okay, so we would find the number. What we would do is we would first design a check function that would tell me. Okay, that's C. That would so I would just design a check function. Okay, so I would first give it a number P. Okay, I would give it a number P itself. Okay, and then I would tell you that yes, this is the number of zeros I want, n is the number of zeros I want, and P is the number. So what I would do is I would first find the number of zeros in P, then I would check if it is less than equal to n or not. If it is less than equal to n, I would return true, else I would return false. मैं क्या कर रहा हूँ, एक P जो नंबर पे मुझे चेक करना है और एक n जो डिजायर्ड जीरोस है. अब P का फैक्टोरियल में कितने जीरो है वो निकालूंगा. अगर वो n से कम है या n की इक्वल है तो वो yes होगा, else वो no होगा. This is what we would do. So we would first save this in temp is equals to P. Then we would count is equals to 0. That means the count of zeros that we would be having. Okay, because I told plus 5 plus 1. And then we would start with the value 5 itself. Then I would tell that while f is less than equal to the value 10. Okay, then we would do count plus equals to temp divided by 5. So temp divided by 5, doing it would automatically be the integer division. It would give me the number of zeros. Then what we would do is we would multiply 5 with 5. For f is equals to f multiplied by 5. So, and then we would return if count if count is less than equal to the value n. Okay, so greater than equal to the value n. Okay, n say greater because least zero. So if it is greater than equal to n, then we would return true. Okay, else return 0 because it is told in the question itself that at least the number should have n trailing 0. लीस्ट मतलब उससे ज्यादा हो या वो हो तो पॉसिबल है, बट कम हो तो वो पॉसिबल नहीं है. तो कम हो तो पॉसिबल नहीं है, ज्यादा ये हो तो ट्रू बताएंगे. Fair enough. So now let us do a quick dry run so that we would have a proper idea for this also. So initially, suppose we take a number 25 because this is the point where we would be adding 1. So first we are dividing the number by 5. 25 divided by 5 doing the integer division would make it 5. Okay. Then we are multiplying. Initially this is 5. Then we are multiplying it 5 with 5. That is 25. Then we would divide 25 divided by 25. And this is 1. So we would add that value also. Okay. Then again we would divide it by 5. Okay. And now 5 divided by 5. Okay, so that is 20. So 20 that is this divided by 5. So we would be getting the value that is 6 itself. Okay, fair enough. So we would quickly move forward to the next value. Now we would do the main thing, that is binary search. Okay, we would return. So if n is equals to 1, okay, if n is equals to just 1, what we would do is we would return 5 because that is the lower value. Okay, then we would initialize low is equals to 0. Okay, Then high is equals to, we can take a large value like n multiplied by 1e5 or something. But this is a intuitive thing that we would take so large value in binary search algorithm that it is feasible. But if we want to be optimizing, and this is an interview question, and the interviewer might tell you that optimize on the high, we would find that 5 multiplied by n is the largest value with n zeros itself. You can do a dry run for many numbers and you would found it by yourself only. And we would initialize the answer, and we know that the answer was persist, so there is no point in initializing answer with something else. So while low is less than equal to the value high itself, okay, then we would find the mid, and mid is equals to low plus high divided by 2 itself. Okay, then we would check this. Okay, we would check for the mid value and the end what is described. Now if this is true, what we would do? If this is true, we have decided that we would go to mid minus 1. Okay, so now high is equals to mid minus 1, mid minus 1, and then we would save the answer also. Answer is equals to mid value. Else, if this is not the condition, then where we would go? We would go to no, and then that would be low is equals to mid plus 1. This is what we would do. So now low is equals to mid plus 1. At the end, whatever value we are getting, we would return it as the answer. Now let us run this for a sample test case and see if we are getting correct output or not. So for 1, we are getting a value 5. So for 5, we are getting a value 25. Let us tally this. 1, 5, 6, 25. Okay. This should be 6. So let us change the value to this also, 6. So let us run this again for 6 value, that is 25 itself. Now we would copy this and we would paste it at that position. Okay. Now after pasting, let us submit this and see if we can get an AC or not. And yes, we got an AC. That's it for today. Thank you and have a nice day. If you face any difficulty regarding the implementation or regarding understanding of this particular question, let me know in the comment section and I would try my best to resolve your issue. Thank you.